Hello, my name is Rouaa and I work on human parasites. War, invasion, colonization. No, I am not here today to talk about human history, but rather about the eternal battle between humans and parasites. Parasitic infections are a big economic and health problem in tropical and subtropical regions of the world. Notably, malaria caused by Plasmodium falciparum is the world's deadliest parasitic disease. Another human disease, toxoplasmosis, is caused by one of the most common parasites, Toxoplasma gondii. Even though its infection is well tackled by a healthy immune system, toxoplasmosis can be fatal for immunocompromised patients. Additionally, the parasite can be transmitted from a pregnant woman to her unborn child, causing multiple complications and sometimes even death. Parasites are organisms that live off other organisms or hosts to survive. The question is, how does Toxoplasma invade its host cell? Well, it is a very sophisticated mechanism, and it's one of the reasons why I enjoy studying it. Toxoplasma does not need an approval from the host cell, and it will not knock on the door. Actually, the parasite will use its own Trojan horse. Simply, the parasite will attach to the host cell and it will inject its army inside. Some proteins of this army will be mobilized on both sides of the parasite, and it will connect its membrane to the host membrane. This is a tight connection called the moving junction because it will move alongside the parasite until it pops inside the cell. Another set of the army will go inside and it will prepare the perfect environment for the parasite to multiply before going out, killing the host cell, and invading new cells. Victory for the invader. What I'm working on during my PhD is a protein that belongs to a different set of this army that stays inside the parasite. This protein is a kinase that will phosphorylate the proteins of the moving junction to enable them to form a strong and a stable connection. Think of it as the person distributing the weapons to soldiers before going out to the battlefield. When we remove this kinase from the parasite, it is unable to form the moving junction and thus unable to invade. This will lead to the parasite death and the end of the infection, and victory for the cell. These proteins of the moving junction are also phosphorylated in malaria parasites, suggesting that we probably have the same kinase doing the same job in Plasmodium. So if we understand the mechanism and the pathway of this kinase, we can use it to make a drug against toxoplasmosis and malaria. So finally, I hope that my work will deliver the first step towards one day eradicating both diseases. Thank you so much for your attention.